So as I told earlier, in case of stack pointer, basically you found that all the single zero address type instruction, that is push A, push B, add C, pop C, and there is no use of any register purpose. A special register, that means stack registers are used here, or we can say also is a stack pointer is there for stack registers. And in these cases, you found that completely our ALU is connected to the stack. In earlier days, in a very early days, this type of computers are mostly frequently used. Now it is very less used. And another is the accumulator versions I have mentioned. You found that here this is actually particularly accumulator. You can write here or you can draw here. Both are same meaning, no problem. Most of the times you found that it's accumulator is written here. So this accumulator is reply back to the circuit. So and others is coming from here as a from memory. So memory can be our main memory, also can be a register also. But here mainly in case of single type accumulator, there is no concept of general purpose register. Only the general purpose consider here we have considered here. So this is the register concept. So most of the time you will find that we peoples are organizing all this situation like in this way. Okay. So if I would like to continue with this concept, that means accumulator based concept, we will presume that one of the operand will be from the accumulator and another will be from memory, and both after addition will be stored in the accumulator, and from the accumulator it will go for storing the result in the memory again. And in this case of I told that once variable come from registers and other will come from in the both these cases are register and other memory. So there is a concept is the register memory, and there is a concept both are from register. So this case can be used here in these cases. Another is that if you go for the next sequences, particularly in general purpose register, why do all new architecture uses general purpose register? So that is the one very important point.
Are the, sir, are the
Yes,
last using general purpose registers, sir?
I have
Is it?
finished this part.
Sorry, sir.
I have finished these topics in the last class.
No, sir, no, sir. I'm saying that is register memory and register load storage using general purpose registers, like those two.
Yeah. But particularly where register concepts are there, most time there is load store architecture, also called as a load store architecture, because every time the register content will be loaded with the data first, and after storing the getting the result from the register, it will be stored in the memory. So every time load and store will be there. Though huge time is spent for loading and storing, but due to the faster access of the register, that is negligible, or the penalty we can avoid. Any other query?
No, sir.
Because I have mentioned here, register are much faster than the memory, even cache also. So register variables are available immediately. When memory is not ready, processor must wait. That is the main problem where register memory concept is a problem. But if you use instead of register is very faster. Why I'm telling that? Because memory is slow and register is very fast. So when from memory there is no data available, then you have to wait for the value, because already register is loaded immediately. But if I instead of this, if I use both a register, so initially a time will be spent for loading the data. Initially time will be spent for loading the data, but once the value will be loaded, so I think that will not create any problem. Once both the register will be loaded, then CPU can continue access uh, efficiently. So this is most reliable and mostly widely used now. That's why in our RISC architecture also, most suitably they have used the load store architecture. So more compact code since small fields specify. But the risk says the one drawback is that less number of instruction comparing others parameter. It is a less number of instruction, and as well as very few very few that means you can say fixed, sorry, not very few, fixed length fixed length of code, not variable length of codings are not allowed here. So that is the one point for these cases. Now, in case of stack architecture, I have given one example that how to evaluate this calculation. Generally, you will find that this type of instructions are written like in this way. Sorry, not this. You can write SCB star plus minus. Suppose, may I write this sentence? If you see, these are mostly look like in this way. So what happened there? Initially in the stack, A will be pushed, B will be pushed. See, A and B will pushed. Whenever they will find the multiplier sign, so whenever that will counter in the string processing, when the system will count, there is a star, automatically B will be pushed, A will be pushed, and they will be applied A star B. Then again push A. Push A means the for this result. So this is where it will be stored in the stack pointer. So it is stored here. A star B already stored there. Is a register load store architecture. After the calculation again there. Now again you are loading A, then again B, again C. Now you are getting the multiplication. So that's reason the multiplication. Again you are applying the addition. So like in this way, finally subtraction along this it will happen. See here the addresses, we can say zero address because directly only the stack it is mentioned, and there is a pointer, we can say top, which always give the top pointer location. So address is not mentioned anything explicitly here. Automatically TOS, whatever I top of the stack we have mentioned, it will count, decrease or increase according to the push. It will increase, and according to the pop operation, it will be decrease. So here it is also called zero address instruction format. Second is that you will find another thing that in presents good code density because the code size is very less. Code size is very less, so yeah, even 5 bit is sufficient because no address fields are required. Low hardware requirement because only one stack pointer is used. And easy to write a simpler compiler for stack. It is very easy to write also. But what is the cons? Stack becomes the bottleneck. Can you say this point why it is become the bottleneck? Anyone from your class? Stack becomes mainly the bottleneck.
So in case of large expressions, sir,
Yes,
uh,
multiple push and pop operation will take place. Then
yes.
what happen? Then
So
what is the
more
problem? We can
storage,
do
so storage issues will occur.
limited size of the stack also because stack is not infinite. Okay, in these cases, in computer, it is not theoretically we can say last in first out, and it can grows like in this way. But in our hardware, it is limited, fixed side of capacity. Okay, and no parallel processing also we can do. The stack itself, size is a problem as well as their speed also issue. Speed is issue because I can't do this multiplication until we can't finish the top one. Are you getting my point or not? So basically his architecture and his principle is the main bottleneck for this one, though there is a code density high and low hardware overhead. Little ability for parallelism or pipelining. So that is very big issue that I have mentioned. So in parallelism or pipelining, which is very essential for us, is not possible in this cases. Data is not always at the top of the stack when need, because sometimes one data which is required, suppose you push A, push B, push C, suddenly A is requirement, but that time your top pointer is this one, then you have to pop these two items, then only you can get it. So that is the one big issue, that even all time data may not be available to in your hand. Difficult to write an optimizing compiler for stack architecture. So optimizing compiler is a big issue. So it cannot be processed in these cases for stack operation. So automatically the earlier thinking or scientist researcher has found new architecture, that is accumulator architecture. In these cases, one operand will stored, or you can retrieve from the accumulator, another from the memory. A little bit programmability, flexibility now increase. Earlier, because memory capacity is huge, so our limited size of stack now can be overlooked here, and due to the presence of the register it is little bit faster also. But again, there is a load store concept, because one data is coming from accumulator, one from the memory. It may be directly you are accessing, but you have to load the data in the accumulator first for doing any calculation. In these cases I have shown. So load B, then you apply the multiplication of the C, then add A, then store D, again load A, again multiply with B and sum D. So like in this continuous loading, calculation, storing, the edu takes place. But here advantage is that you are now using a separate memory. So very again there is a very low hardware, but easy to design and understand. Very easy to design. Accumulator becomes the bottleneck. Why accumulator? Because the size of the accumulator is fixed. One thing, and second thing is that accumulator only can be loaded from outside if marks based architectures are you consider. Otherwise, parallelism pipeline here also not possible. Can you explain why this is not possible? Here also very little ability, you can say, because sometimes both the sources are not free. One is free and one is still not in my hand, or special purpose register only the ALU can store and can ALU can retrieve. So that is the one big problem for this architecture. So this is earlier used. Now it is memory architecture, you can say, where you can say register memory also one architecture. Fewer instructions, especially 3 operand, easy to write compiler. In comparison earlier, where you have to write so many instructions, in load store architecture concept here, very less numbers of instructions are required, fewer instructions set. And easy to write compiler for especially 3 operands also. Very high memory traffic, because simultaneously you are using multiple memory. So that is the one big critical problem. Variables numbers of clocks and instructions are there, and with 2 operands more data movements are required. So clock cycle will be very high, because in general cases maybe in RISC architecture one instruction plus one clock cycle, and all are single instruction clock cycle with fixed set of instruction format. But here, when multiple memories are exceed, memory 1, memory 2 and memory 3, when all are multiple memories are exceed, what happens then? You have to retrieve the memory cycle, and memory is slower, so multiple clock cycle will be wasted executing a single instruction. So that is the one bottleneck in this problem, but otherwise very less numbers of instructions are required. Now this memory concept can be further activated as a register memory concept, and whenever register is there, there should be a load store concept as I mentioned, and someone has asked also. So this is should be remembered in your mind. Whenever there is any register memory concept, load store computer architecture will be there. So that is the one big issue for this one. And now you'll find that in case of ALU purpose, memory purpose, since the register memory architecture is there, so some part advantage you will get of the registers and some memory. So some data can be accessed without loading, and instruction format easy to encode and good code density here. But operands are not equivalent. Variable number of clock per, that is the one big issue, because load store may be very fast. For memory huge numbers of instruction will be required. So this is the one big issue. May limit number of registers here also, because simultaneously only from a register bank one register at a time only you can use. So it can limit the purpose of the register. That is the one issue. Second is that if I use both load store, so in previous cases, I am not telling the entire load store architecture, because in the memory, you can directly access. But when register architecture is there, which also we call general purpose GPR, general purpose register, fully we are using in this case here GPR concept. I think Prajata asked this question. So here we can say this is the load store architecture, very effective, and particularly for embedded system, we found that this architecture is very essential and mostly used also there. So you find that every time each of the instructions will be loaded. Once the loading is complete, then it becomes very faster and very less numbers of clock cycle will be required in these cases. So maybe some time will be wasted for loading, but once loading is finished, then the program will be very faster. And that's why this is very important and very useful for pipelining also. Sometimes you are loading this and you can compute this purpose also, because that time the unit required for loading R1 R2 are free, then you can do this one. So you can achieve parallelism in this cases. Simple and fixed less instruction, because all are same type work and same natures and same number bits are used. And the particularly fixed length, I am saying that if you are using only one address or two address, only two address are simultaneously used. That means if you are taking a load R1 with some memory, that means always you are using only one register at a time and the memory contents is loaded. So what are the number of bits required for the instruction for all, maybe R2 M, like in this way it will happen. Instruction takes similar numbers of cycle. That is the another very important point, because here length of instruction, and since they are using same resources, so same resource in the sense I am telling all are using resistor. So it is a very similar number of clock cycle, relatively easy, and this is a very important point for pipelining. And modern days, most of the computers are trying to implement also trying to implement the RISC architecture. But the number of instruction may be high for a simple examples, and not all instruction need three operands dependent on good compilers. So these are the different pros and cons for a particular computer architecture. Now we'll go for another one, that is called um, some advantage or some disadvantage there. Every IS design instructions architecture designed after 1980 uses load store. That is a very important point. Remember this. Mostly now load store, and there's also called RICs. Those six are still used in our Windows operating store, something else. But due to the high speed architecture in a mobile computing or Android, mostly they are following this type of architecture. Need to save and restore on procedure calls and context. So this is the one problem when you are using some procedures, because sometimes you are running some execution and during the line of the code you found that you have to need some procedure, then again come back to the point and again you have to continue the task. So if there is a call procedures also, so you have to store up to that state somewhere in the stack pointer maybe, then you go execute some code, then again come and from the stack pointer again to be loaded, and then you continue. So for that purpose, save and restore on procedure calls the redundancies for this architecture. Cannot take the address of the register for pointers, even only register can be loaded, and from the register it can be stored to the memory, but register addresses cannot be manipulated by you as a pointer. And it is a fixed size. That is a very important point, that though it is a fixed size, so expanding opcode, whatever, okay, expanding opcode concept not cannot be implemented. The variable code length, today we will study expanding code length advantage also, that cannot be possible here in these cases. Now you will find that word oriented memory, that I have told that work computer memory is a byte addressable. You can store 1 byte memory per particular location. Sometimes that is in these cases, sometimes you can use like in this way format, and sometimes you can use 32-bit word as a particular memory. Here 1 byte per, here 64 word, or you can say bytes per location, and here 32-bit per location. Likewise you can use memory is byte addressable. So there is the our default consideration in your any mathematics or numerical problem. You remember that is byte address provides access for bytes. That means 1 byte equal to 8 bits. Half word they mean 16 16 bits, and here 32 bits equal to 1 word. So by default they are considered word 1 word equal to 32 bit. It means that how many bytes? 4 bytes. And double words mean 64 bits. So address of first byte in the word and address of the successive word differ by 4 if you are using 32 bit, and if you are using 64 bit architecture differ by 8. That means if one address is 000, next address will be 0100, like in this way, 000, 8421. It's okay, 1000, like in this way. So because 4 byte at a time you are using for particularly single data, now next data will be like in this way. So you can use this also for your purpose. Next is that microprocessors, and one is microcontroller. You will get this concept regularly. Be careful. Microprocessor and controller. Microprocessor is more flexible. It is more flexible. There is the advantage, but it is application specific. Application specific, very suitable, and also, and it will found that most of the time for embedded application, it is most suitable. What does it mean? Our CPU, CPU is nothing but control unit plus ALU. That is our basic concept. In the processor only these components are present, and rest of the components are as per our computer organizations are added. Maybe memory or IO port, all these things. But in contrast to the microprocessor, in microcontroller, CPU and rest of the components will be in a single chip. So you can say it is like a system on chip concept also. So microcontroller, you can say in a particular single chip, all the components along with the CPU are combined. Though I can't say only main memory or ROM, RAM, BIOS, everything on a single chip. And here you can using SATA cable or maybe some data cable, you have to connect to the CPU to the other for your person. So it is a single chip. It is not a single chip. Consists of memory IO ports together. Here memory IO ports to be connected externally. So this is the one concept which is used for particular application, but flexibility high because due to the that means additionally increment or decrement memory size can be expanded, IO ports can be expanded, or as well as required we can do by USB port or something else we are attaching. But here in this case, whatever you design, during the design you have to fix the architecture, and once it is developed, it is fixed. You can't alter. So particularly in embedded system, whenever you design particular application, accordingly you will implement it. So 8085 microprocessors will be taught by your teacher, Amsha ma'am. I think she will explain all these things during the classes. So today, after that, we are going one more. In the instruction, we found that these are the three part. Okay, what are three parts? First part the opcode, second part is the address or maybe immediate value. So this part can be also present here. So like in this way, I found one part is opcode. So I will come this point. First of all, that means you give me that I have finished this part, remainder one. So we'll go first. That means what we call uh, opcode expanding. Opcode expanding. Okay, this is very important part. We'll go for the Oxford expanding also after this session. Okay, so first of all, as we mentioned earlier, that addressing mode, though directly I am not writing anything. Directly I am not writing. Here I am not writing directly. But what happened that implicitly it is present. You can say implicitly actually meaning is present there. This code is implicitly present because of the purpose we have to do, that means effective address. I can say effective address calculation. Effective address, what does it mean? Effective address, some data is directly present on the memory, so you can fetch it to the register. Sometimes in memory it contains the address of the data where it is present. So first location you will go here. Here you will find some address, then you go to the address and then you fetch the data to the register. So maybe indirect or maybe directly data can be present, and from the memory you have to write. But how can you understand that data is present directly or we can get it? So various techniques are there: direct, indirect, immediate, implicit, register, register index, displacement, retracement, maybe relative, base register, and indexing and stack base. So these are the different addressing modes are there. So among them we will study gradually one by one. In register direct, you see, if I write add R3 R4, it must be earlier instruction was R4, maybe from memory or maybe 2 something is loaded, then another load value R3, maybe something M3 star or 3 some location minus, maybe M1 maybe M2. So this should be loaded and this should be loaded. So here is there, in case of this one, directly register value is calculated from the register is accessed, where the effective address means that data is always present on the register. That means whenever you write this type of calculation, they'll understand CPU what will do, directly go to the register bank to get the data. Sometimes immediate mode, that means nothing loading is required, only one value whatever loaded in R4, that 3 will be directly added to the content on the R4 and the R4 will be updated. That means data is updated. And now displacement, that means some memory location, you have to go to the some memory location. In the memory location, you have to add the value of R1 with that value, then you will get the actual location of the uh, memory. So that's why the value of R1 is added, incremented some constant value, that is 100 in these cases, then go to the location and get the data, then it add with the R4. Then again there is a loading, it must be there because R1 must contain some index value that should be present. In register indirect, that means one value is registered directly present, but if I give some braces, if I give some braces to under meaning that register is not directly accessed, you have to go in the register, you have to go in the register and register content, where a register contains some address where some data is present. In earlier cases, both the register contain the data, register contain the data, but in this case a register contain the address of the data. So in this case memory are affecting as the memory indirect also possible, that is the memory indirect I have mentioned. Directly memory accessing is not there, in this case a direct memory, see I have given the bracket. So direct memory instead like indirect register is means direct memory. If I mention a memory address and the memory direct input like in this way. So gradually, these are the different mode. Auto increment, auto decrement also will find. I will come to the point once I explain all the mode directly one by one. Suppose in the immediate addressing mode, operand is the part of the instruction and operand equal to address mode. So here operand is a part of instruction. That means the value will be directly added. Suppose I am writing add 5. See, operand is the directly associated here. Okay, so operand will be present in the address field. So add 5 to the content of accumulator. Or if you write add R1 comma hash 5, 5 will be added to the content of the R1 and R1 will be updated. No memory reference to fetch data. If you write in these cases, no memory reference, directly access. Here only a one register access. Very fast and limited range, because If I using two address register, it means that one is occupied by the value, only other register you can use simultaneously if you use two address format. So limits the memory reference, but yeah, the range limited, but it's very fast because directly they will compute the effective address will be calculated, or maybe the memory location directly will be encompasses. So like this is the immediate addressing. In the direct addressing, the effective address is the address field of A. So here you can say in direct addressing, that means your opcode, some value will mention, directly go to the memory. It does not mean after going to the memory, you have to go other location to get some data. In the memory, it is present the data itself directly. But memory indirect, if I write indirect address mode, that time memory had no operand. Here will be some address, and that address if you go, you will get the data. So that is the indirect memory address references. So memory cell pointed by the address field contains address of the operand. Now look into the find address look 3 operand actually. It is memory indirect because this indicate the memory referent. So I will come the addressing point again. Before that, you just mentioned that in opcode expanding, we use some concept half-man opcode analysis. Okay, half-man opcode encoding. We will use half-man opcode encoding. So for time being, I am stopping this part here. So we'll again come back in half-man opcode encoding. After that, we will again start addressing mode. So any question on the addressing mode, you can tell me now. Any questions? From your side, any questions, you can ask me.
Sir, what is the displacement addressing mode? Sir, how does that work? I didn't get it.
In displacement mode, actually, sometimes in the memory, whenever we go to the memory, in memory, we will get the data. Memory will directly we can get the data, or memory will contain the address where data is present. So both are direct indirect memory references. But sometimes if you specify that my data is present, the location of the memory plus 10, some constant value will specify. Okay, so what will affect address? The contents of the memory plus 10, not as a normally byte addressable 4 byte or 2 byte automatically will go. No, you now giving the displacement. What is the value of the displacement that I am considering? After 10 location, my next data will be stored. So automatically the displacement will take 10 bytes. Are you getting my point or not? So actually you specify the location where to be data to be searched.
So what is the advantage of doing this?
Its advantage you will find particularly in case of programming. Suppose a branch instruction you have to load it. So you have to display some memory location and then go for the other consecutive, because consecutive memory location you can't store it. Or also you found that the memory consecutively filled up and your next location after some priority, because the mapping scheme whatever you used in the map, simultaneously all the locations are not be occupied, but your next memory location, the next value to be accessed, you have to leave some blanks in the memory and go for the next location. Only that time displacements will be suitable. Did you get my point?
Yes, sir. Yes, sir.
Hello, sir.
Yes.
So, what is D in the scalar mode addressing, sir? When we use a square bracket, we use multiply by D. What is D, sir?
Which one? I'm not getting your point. Which addressing mode you are telling?
Sir, in the scalar addressing,
Yes,
we
scale. Yeah,
bracket.
yeah. I have not explained. I will explain. Yeah. It is a indexed pass as well as register. I will come to the point. I will come to the point because I need to give example and then I have to write. But in the meantime, due to some warm homework application, I have to teach some other topics and then again I will come back to the this part. Okay, this part needs some 1 hour session, but we have only 20 minutes left in our hand. Getting my point or not? So cannot be finished. So that's why up to memory indirect, that means seven, number seven, I have finished. Just I think slide is not visible to you, no?
No,
Is
sir.
slide is visible?
No,
Not
sir.
visible.
No,
No,
sir.
sir.
It now visible. So I think up to seven only I have shown. Okay, seven. These only I have explained. These three, these two, 8 and 9 is very complex and less used, but very complex. Auto increment, auto decrement. See, you will find that here. In these cases, just 1 minute. It's very clumsy. I'm erasing all these things, so little bit it will be clear. Just 1 minute. In these cases, see, whenever any instructions are calculated, particularly, that means you are calculating some address here, the address of the register, you are adding the value of the register R4 with some contents here R2. Now, since basis is given, it means that you will go the register indirect or memory indirect. These cases, it is register indirect or memory indirect. Register indirect, because directly I have specified the register. I have specified the register and then I mention the braces. If I give some memory M or some value like in this way, then I can say the direct reference of the memory. But here we can say, though I have given ampersand sign to mention that it is a memory references, but generally I can specify memory indirect also in this way that the register contains some address. You go to this location first. That location contains some address of some memory. Go to the memory, and from the memory you will go to the actual references. So it looks like in this way. Suppose I'm opening a page. It is a register. Okay. So when CPU or asks this register contains upon X. So in the memory, some address location value is X. Go to that location. That location contains some Y. Go to the Y, and Y contains my data. So one clock cycle to access the register content. Then you go search to the memory. In the memory need another, you have to search to the memory. So one reference from register, because register contains some data. Then go to the memory. Now you need memory clock cycle. Maybe this is for one clock cycle and each memory operation 2 clock cycle. Then again you have to go to the location Y where Y is present. Then it contains the data. To fetch the data, how many clock cycle? To access the register, access register need some clock cycle, maybe one cycle. CC. Now X you have found. Now go to the X location. You found the address of the other location. Now access the memory. Then maybe two clock cycles suppose. Go to the memory. Then again access to the Y location. The access of X location, the access of Y location. Then again clock cycle. So 5 clock cycle is become to access particular and register. But if it is a register indirect, suppose it register indirect. Sorry, suppose it is register indirect. So what will happen there? In these cases, particularly, sorry, not register indirect, memory direct, register contains some value, no problem. Directly you go to the some memory and you got the data. It does not mean that you have to go but another address. So indirect, it is indirect, it is not required. You go to the direct, you will find out. Now our point is that why not we are using register indirect or register direct concept here. Suppose
Sir, are you writing something on the screen, sir?
Yeah, I'm opening and then I'll show you. I'm not writing now. I am just trying to opening the file which I have to show. Anyhow, I have missed it. Again, I am bring back to show you. In case of indirect, you just now it is visible to you, I think. Effective address, you see, is visible.
Yes, sir.
Okay. So here, effective address calculation in indirect addressing mode. You will find that mostly here, first of all, you go to the address. You are going to the address. Now here data directly not present. That means here in case of we are writing operand, this is my data to be fresh. Now it contains the address. Maybe it contains the value of x. So here is the x. So you have to go to the x location, then you fetch the data to the your memory purpose. So in these cases, maybe it is the one register because you know in CIR your data instruction is present. Am I correct or wrong? This is for opcode for the decoding instruction decoding part. And now when I found some address are present, then you have to go to the address. So you have to go first the address and from the address. So this is the indirect. But if you directly get the data, you go to the memory location, get the data, then it becomes direct. So this is the memory direct indirect. In register address, directly register contains the data. No need to go for searching to the memory. No memory access. That's why I mentioned this no memory access. Very fast execution, but address space are limited because our number of registers are fixed and very less. Multiple registers, if I can simultaneously boost the performance. Okay, so you can say it is a one type of direct addressing in terms of registers. Now this is the register addressing diagram I mentioned. Instead of memory, in our memory bank, it was memory. And in case of register, it is a register bank. Directly they go and get the data. In register indirect, register itself contain the address of the maybe anywhere in the register bank. So it becomes indirect. Are you getting my point or not? So memory direct, register direct, memory indirect, and register indirect also possible. What is the difference? The difference is that here, in case of registers, whenever you go to the register indexing addressing mode, it contains the pointers to the operand from in the memory also. There is a possibility in register indirect. In the register mode, if you go to the, you access the value of the register, directly get it. But now register you go and register contain the address of where memory locations are present. So here in register indirect mode, you are finding the presence of register and RM. That's the why we mentioned register memory concept in earlier architecture. They can access it frequently. Now come to the displacement. Here is a base value. You find that A is the base value and R is the register that holds the displacement. It may reverse also possible. Be careful this point what I mentioned. Vice versa also possible. So register can contain the base address and other contain the displacement. Now if you notice to the displacement, you will find that register know the operand to be fetched, but I have fixed the displacement value where to be searched. Maybe here I will mention 0. After that, you go 10 location, I mention the 10. So here you will get some displacement value that will be added to get the calculation. In earlier cases, register indirect, directly you go. So question may come, is displacement indirect mode or direct mode? Can you tell me? Displacement addressing mode is direct mode or indirect mode?
So indirect.
Sir,
Indirect.
indirect.
Yeah, indirect, because directly from the register we are not getting the data. Advantage or disadvantage may be there, but problem is that it is flexible increase the programmability. You can program your memory now. In earlier cases, due to the absence of the displacement, automatically according to the byte addressable architecture, 32-bit or 64-bit, it will access the location. But here location specification in your hand, by using your displacement you can specify which location to be searched. Am I clear what is the difference between the displacements and indirect references? Question asked by one student in the displacement. Is it clear this point?
Yes, sir.
Hello,
Otherwise,
sir.
make it. Yes, sure. Very good. Tell
Sir,
me.
sir, I want to ask one thing.
Yes.
Sir, direct mode is anyway going to be fast as compared to the indirect addressing. Then why we are discussing about indirect addressing?
Required sometimes because see, memory is very costly and limited. Sometimes you are using some instruction which already used all the data continuously, all the location code. Maybe you are using 5 data at a time. Each of them are 1 byte. Now you need some second data for some other purpose also, but that time continuously after the one instruction you cannot be loaded. So somewhere in anyhow will be loaded. Are you getting my point or not? My question is there. Sometimes you can say best practical example, like suppose what can I say, one suitable example. Due to some problem, you will not be available for certain period in the unit room. Maybe you have a class or something, but you told your security person of the hostel, if any letter come, please tell him to submit to the Prajata's room. I will collect from Prajata. You can say like in this way. Am I correct or wrong? You have
Yes,
some
yes.
personal obligation. You have some personal obligation. Same thing in the memory also. Sometimes it happen that there is a very less chance that according to the policy, because when I will teach you cache replacement policy, there is a associative policy. That means how each of the locations are associated each other may not be directly, may not be direct mapping, not possible. So automatically it will go to the next location, or maybe I will specify that after 4 byte it will go to the next. In the associative set associative or associative memory mapping, I will teach you that why this is not possible. But at this moment, you just assume that continuous memory location may not be possible because of the policy of the program or the system. I have to store indirectly, then I have to access it. So that's the requirement according to the demand of the program or architecture you have to do. It is not that I know event is slower, but we have to do. But sometimes it will be more advantageous to store a particular, because suppose always direct you need lot of memory override, because suppose you always think that I have to always store in the first location all the odd data in the odd location, all the event data in event location. You adapted that policy for storing the value or accessing the value. Then it may happen that if you use 10 location, then 5 odd and 5 even, and you are using 5 odd and 5 even number, there will be no problem. But all the odd numbers, then there will be some problem. Are you getting a situation or? So somewhere I have to go for the odd location where I have to store some value which cannot be directly stored in the location because the memory is not free. So that is the problem of the memory adjustment or memory management. I will discuss more there. Is it clear? Shangam, your question is clear?
Yes,
Every mode
sir,
has some
clear.
pros
But
and cons. Bolo.
one,
What?
sir, one confusion is there. You have talked about memory is costly, sir.
Yes.
Then then in which addressing mode it will be more in direct addressing or direct addressing?
See, memory is costly, but your program needs to be stored some location in the memory. It's a programming application. It may happen that you need one data, you are storing that data here. Maybe some data here, data one you are storing for some instruction I1. But what happened there? Suddenly you need another instruction I2. But you don't know how much memory of I1 is required. Now you are, what happened that you are now storing the value I2 here. Suppose Now you some value of I1 is required, but that memory is not sufficient to store here because limited number of size. Then what can I do? Maybe I too require huge data which is not as per my size. I can store where the data is present, maybe X address. Only I can store the value of X, and here bunch of all the consecutive data is there. Are you getting my point or not? Because you are now sometimes you are using 1 GB data and someone using 10 GB data, and 10 GB data I can't store here directly, but register you always use the memory. So what happened, that 10 GB you are storing in the secondary memory, and the address of the secondary memory you are storing in the primary memory. So CPU will go there and then it will go to the location. It will be easy. That means at least you can access it without storing in the main memory. Are you getting my point or not?
Yes, yes, sir.
So in these cases it can be suitable. Always direct will be helpful. Here direct will not be helpful to store because due to the size of the memory. But it can address, you can specify, you can show. That is the pointer application. Pointer is always indirect reference to the variable. But you know, pointer is mostly suitable for manipulation or operations because due to the memory management. Am I correct or wrong? So
Yes.
this is the one scheme. Another is the, I think little bit clear, even not clear. So memory management, I will teach in my second session, that means second slides very soon. That time I think this part will be clear too. Okay. Again, raise the voice when I will teach you, particularly set, associative, and direct mapping. When I will teach all this point, that time raise this voice to me, sir, why indirect was very essential. Okay.
Okay, sir.
Okay, but for time being, you understood that some main memory location I can store this huge amount of data directly due to the less size. Even framing is not possible. If framing possible, I will fragment and store one by one fragment. But suppose that if I can store the address of the location and from the address I can keep all these things, it is happening. It may happen that in your Almira there is a small locker and you can't take all the item here, but there is a big Almira, you have kept all the item, but actually this item should be kept here. Then what you have written here, you have written this item is kept in this Almira A. So you written the address. You know all the your clothes are there, no problem. But one item you found where address of the other Almira is given, where you have given the winter clothes. Suppose. So you can manage like in this also. Are you getting my point?
Yes, sir.
So I think like in this way, we can do further operations in these cases. Now another is a very important is that there is a very important, why I'm telling you a relative address. This relative address not applicable for all register. This is applicable only special register, that is you found program counter. Here program counter is efficiently used for calculating the effective address, and particularly this is locality reference and cache uses. Again, it is coming what is locality references. I told that locality reference, that when you are accessing some data and it requires some next data to be fetched from the memory, you found that the data is very near to the memory location. You will be search the location and load to the memory. That is the one application. I give the example that whenever you're searching your friend, you know your friend always present on the hall number 2, room number 35. When you go to the location, you found room number 35 is completely vacant, the person is not present. So as per your normal curiosity, you will ask 36 or maybe 34 whether he present nearby room or not. This is the first our common sense applies. So same thing is applied in our uh, cache principles also, locality reference. If some location you are using, there is a huge chance that is next consecutive location, previous or after maybe, will be accessed soon. So automatically computer PC will be loaded with the content of the next memory location if there is no branch or jump instruction. Again, another principle is that you found that you are accessing a particular location frequently. Anyhow, you found that this location will be accessed soon in near future also, or you can say this will be accessed very next 5 consecutive time also. So what will happen, instead of every time going to the home or hostel, you bring back to your classroom these books regularly. That will happen there in each class. you found that you require logbook for mathematics calculation. So what happened? First class you went to the hostel, bring the book, perform the task and submit it. Maybe in third class again logbook will require. Then again you will go to the third class again bring back. So it is better instead of going back, you keep it in your bag with you that you can frequently access it. That means nearby CPU location it will be there. So that is the one of the locality of references frequently used. So in program counter, it may happen that some location will be frequently used, and specifying the location of the memory, you can modify the content of the PC. I told that PC is a special purpose of register which points the next instruction to be executed. Now you have the chance to modulate the content of the PC, because PC point the effective address directly as per our knowledge. But here we are appending the value of the memory location also appending with this one, then effective address. What does it mean? That you are now guiding the PC to which location you have to go. This is the one of the another version of the displacement addressing. But in this displacing mode, since relative only PC is used, because the pointer PC program counter which is automatically updated, now you are modifying with your programming capability. So that's why it is a relative value, not as a normal or generally whatever increment happen it will not follow. In base register, the register holds the displacement. In earlier cases, effective address memory contains the displacement value. Here base register, it holds displacement value. Register holds pointer to the base address, and R may be explicit or implicit, whatever may be. Now, as a best example, that in this cases you will find this is a base register where R holds the pointer to the base address and A holds the displacement. In earlier cases, in case of here, A contain the base address, suppose a current location pointed by the PC, that means get operand from a cell from current location pointer to the PC. It means that directly PC pointer value will be added to the A, and directly you will go to the that location to get the value. Here PC is explicitly used, but here no PC. Here a register, normal register contains the base address and the displacement value contains by the memory. Add these both two, you will get the point. In this case, remember it is a base register. In base register, register contain the base address and memory contains the displacement. In this cases, index addressing mode, A contain the base, R contain the register. So this is just reverse of this one, base register. Am I correct or not? Am I correct or wrong? See, initial base address may be 1001. After that, your I value, I counter 1, 2, 3, you do the incrementation, individual memory accessing. So the register contain the index value, and automatically index as per index value you will be accessed. So that's why good for accessing the array structure or arrays like memories. And that is, once base address is there in the memory, and the displacement automatically done by the as per your data type also. In our C programming, it is 2 byte at a time. Am I correct or wrong? So displacement 2 byte in integer mode. I clear or not clear this point?
Yes, sir. Yes, sir.
So displacement here is a 2 byte. In the base register, memory, that means register the displacement, and this is the base address. So it is a segment register, special purpose. It's very less used, but this is very frequently used, index register. See, so I found here three type of displacement. If I combine, one is PC, that is we mentioned relative. Be careful, very try to understand the difference. For the relative, one is base register, one is index register. Register contain the index part, register contain the base part. It is special character segment register, and this is useful for array. Okay, and PC In program counter, actually the main purpose of the register. In the PC's cases, A may be the displacement, PC contain the base address. Okay, in case of relative. So here register is special register. That's why we mention relative. So in earlier cases, you will find that completely if I say compare these three, which is very you can say important for our addressing mode among these three displacement, which is very effective. Three displacement I considered. One using PC, one a PC and our memory. Here A plus register, where register contain the base address. Here again A plus R, where A contain the base address. So that is we can say indirect index register, because register is the indexing, A contain the base. Here is the A is the base register, so it is I can say base register, and it is a relative. So these are the three displacement. In both the cases, displacement takes place. In these cases, where a register contains the index value, displacement contains as per the index value. You can say it is a regular. In jump instruction, particularly in jump instruction, where you are doing sequential, suddenly you have to jump certain location, you need this relative parameter. Am I clear or correct? This point is clear. For jump instruction, when you are doing some sequential for suddenly for a condition satisfied and you have to jump to the another location, maybe it is not continuous for a so much, maybe you are doing 100 200 and this is the 4000 maybe location, so you have to jump. So that time PC is continually modified, PC contain the base address, but the displacement contains by the memory, and then the value according to the program you jump and go to the location. So that time content of the PC is used, but here content of PC never changed. Are you getting my point? Content of PC will be specified only by the register, base register and index. So memory accessing is very helpful in these two cases, but this is special application for instruction addressings. Am I clear these 2 points or not? Here I have mentioned all these things separately. Pentium army addressing mode are using. So see some examples I have given. Can you tell me what type of addressing mode this one? What type of addressing?
Sir, memory, sir.
Not clear. Your voice is breaking. Little bit. Can you? Yes, yes.
So it's general purpose. So general purpose register
No.
method.
If I give this type of, you must remember that is it is memory indirect. Just remember it memory, because I am not reading R1, R2, R3. I have nothing written. A, B, C, D I have written. So it is directly you mention that whatever A, B, C, D I have mentioned, it is a indirect addressing mode. Okay. And that's I mentioned there. This uses, I use separate color. That means I use blue color. This uses indirect addressing mode. Okay. Now A R0, that means R0 contains the index and A contains the base. See, index addressing mode. It is clear. Just now we discussed index addressing mode where R contains the value of the index. You like I equal to 1, 2, 3, 4, like whatever increment value that contained by value of the R, and A contain the base address. The first operand is the destination, uh, and this was the source, and the second operand that I mentioned the source uses indirect addressing mode. Very good. A and B are memory address residing at the second and third words respectively. The first word of the instruction specify the opcode. Okay, so in the, if we say like in this way, so I can say this is the opcode, this is the register, this is the register. Now how you are using, there is a very important part for all of you. That is very try to understand it also clearly. Now what happened there? The index register, destination and the source and destination addressing mode. I mentioned properly. Okay. During execution of add instruction, the two operands are added. Okay. One operand, two operand are added and stored in the destination. After that means you can say A plus B, I am storing in the A. Are you getting my point or not?
Yes, sir.
Is this clear? I am adding A equal to A plus B and finally I am storing there also. Okay. Now my question is that whether they are mentioning I'm just rubbing this point during the execution what they are mentioned, but actually we are doing all the operation like in this way. Okay, so that is the one thing, very good point to all of you, try to understand. Now again I'm repeating that during execution add instruction, the two operands are added and stored in the destination. That means a n plus we are adding and then again we are adding the destination. The problem is that a also not direct, B also not direct. Am I clear this? Both are not directly. First of all, the number of memory cycle needed during the execution of the cycle of the instruction is how much? So we have considered one instruction at a time required. Okay, byte addressable memory. So we considered here that means one at a time is required. So for one read operation, one read for first operand, second for second operand, and one for write. Then you have to first come to the point two read operation for second. This is the very important point. Why? Tell me.
Sir, since this is a memory indirect, we will.
Yes, memory indirect. That means you first go particular location, maybe X, and X contain the value of B, suppose B, suppose like in this way. So to first go to the location, you need the access this location which contains some address. You go to the another location. So here one clock cycle, here one clock cycle, two clock cycle. It is clear this point? Two clock cycle. And it is indexed addressing mode. Index addressing mode is base address maybe 500 suppose, and index value might be 1, directly 501, and now directly go to the 501 location, you get the data. So only one memory access, but there is a calculation which takes place but negligible time.
Sir, could you
How
repeat
many?
why it's 2 clock seconds for the read part?
Okay, because it is a indirect memory references. It means that for accessing the B, you have to go certain location where actually some value X is present, but is the X is the memory location, maybe X here. You go to the location again, then you get the value of the B. Suppose. Okay. Now to access this location, one memory for this reading, but it is not directly contain the value. It contains the value address of the value where it should present, then go to the value where it is present. So another memory references. So two references required here. That's why 2 clock cycle. Then you finally get the data. In direct read, only 1 clock cycle. But here indirect read, that's why 2 clock cycle. Is it clear?
Okay, sir.
Not clear? No. If there
Yes,
is a
clear.
doubt, then tell me.
Sir, it's clear now, sir.
Not clear.
Sir, it's clear, sir.
No, sir, it's clear.
Okay. Otherwise, that I am not wasting your time. Don't like in this way. You can ask multiple times. So that's why in the first read operation, effective address is directly calculated by the registers and base address. Okay. So effective address directly will get, and again directly write the value to the memory, one write operation. That's why 1, 1, 2, and 2. Total flow clock cycle. The exact answer will be flow clock cycle. Okay. Now you see here I written AI equal to BJ. That means I and J some index are there. Okay. And A and B are some memory, or you can say A or B contain the base address. So what type of memory location is this one?
Sir, indexed addressing.
Addressing, sir.
It is index. Okay. And here automatically incrementation will is there. So it will be auto incremented. And since pointer is a direct, direct reference of the memory, it contains the address of the other variables. So it will be the indirect address. In the question, addressing mode, I will give some question like in this way, and you have to match with the different addressing modes also. Is it clear?
Yes,
Yes,
sir.
sir.
Yes, tell me. So up to this, today we are stopping, or I can continue. Don't worry, I can continue because a lot of things are there, but it depends upon you. At least one more mathematics, okay? Can you tell me what will be the value for this one? Solve it and tell me. Though I have solved it, you check, cross check whether it is matching with you or not. See, the memory location 1000. So write a memory location like in this way. I am trying to solve it. Memory location is 1000, where same data is present. Then I made 1001 like in this one. Finally, I'm writing 1020. So here 18, here 1, here 16. Now move RS1. It is immediate mode because the value directly is given. Clear? So you are getting RS value how much? 1. So your register contain the value what? Tell me. You just explain with me. You 1. Okay. Now load RD. Now 1 register RD. Load RD. What? 100 plus the content of the 100 is the base address. 1000 base address. R is the index. So it is a what? Index register. Index register mode or not?
Yes, sir.
Yes, sir.
Yes, sir.
In index register, base will be directly calculated. So 1000 plus 1. What is the RD's value now?
So 1001.
And
Sir,
RS
one,
value is 1001. 1000 plus RS value. What is the RS value? 1. Because see RS contain what? 1. Not clear?
Clear, sir.
Clear, sir.
नहीं आप लोगों को लिख लिख के करना होगा रे भाई. हाँ. Suppose this is your RS. This is your RD. RS1. Is this clear? Move. Move immediate. That's why I written move I. That means 1 will be loaded in the RS. Then load RD with 100 plus RS. 1000 plus RS. RS value how much? 1. 1 plus 1000. 1001. So what is the content of the RD? 1001. Now RD will be added with the 1000. Add immediately. What is the content of the RD now? Tell me.
So 1001 plus 1000.
Then it will be
2001.
2001, sir.
suppose. Okay. Suppose 2001. That is the main concept we are following here.
Yes, sir.
Now, as per our convenience, since you are loading the value to the RD, now what is the content of this here? 1001. Now go to the 1001. What is the value of 1001?
1, sir.
So what is the content of the RD?
1.
I am writing here, people, you are following. That's why follow the instruction. It is the load operation. In load operation, RD will be loaded with the content which is present. In earlier cases, it was immediate direct. That's why one was directly loaded, but it is not direct. Are you getting my point or not?
Yes, sir.
One student has told from your side it will be 1. Who is the fellow? With understanding or without with just seeing my answer? One of you maybe answered it correctly, huh?
Sir, I kind of understood it, sir, because it is reference,
Okay.
sir.
I am repeating it. In these cases, move immediate 1 will be loaded to the RS directly. So the content of the RS was 1. There is no headache. But in this case, loaded the content of the RD. Now RD I have to load it with how much? 1000 plus 1. Go to the location. 1001 come to the location. What is the value? 1. So RD will be 1. Is it clear? Now content add. Now it is adding immediately. Immediately adding, that means RD's content will be loaded with the 1000 and its content 1. So 1 plus 1000, it will be 1001. Now content of the RD is 1001 because it is add operation, not loading, that I have to go to the now store 20 in location. Storing operation is like in this way. Okay, so you will be now store RD location. What is the RD's location now? What is the RD location? RD's value is what? 1001, 1001, and base address 0. 1001 plus 0. Total effective address will be how much? 1001. So go to the 1001 location. That means that location and store 20. So 20. So after execution of the value, what will be the content of the 1000 memory location? 1000 will be 20. No. Memory location 1 is a value of 20. No. Memory location 1021 is the value. 1021 is not there because I have not considered. No. Memory location 1000 is the value of 20. So that was the correct. Got the point?
Yes, sir.
Student, try to understand. This time I will set the question paper. In this question paper, I will never give any theory. All will be mathematics, whether it is an open book or it is a closed book, there will be no difference in the examination. If any doubts, clear it now. Otherwise, a big issue will be there in the exam. That's I told you this semester you got a tricky subject. Any doubts about this question?
No, sir.
Anyone? No question?
No,
Okay.
sir.
Sir,
Interesting?
sir, one question, sir.
Yes. Yes. Yes.
Sir, I did not get the move RS part. Like 1001 is where one
Yes.
is located. Like the memory location has data value 1. So
Which
we are.
instruction you are specifying? Which instruction you
Sometimes,
are first tell me?
sir, I'm first saying about the given part, sir. So just the given part, like the red part, sir. It said
Add one.
1000 as
This
value
one.
18. No, sir, the top of like before the command,
Okay.
sir. So
This one. Okay.
yes,
Then
sir.
first you have to write like in this way. In the given part I am writing, it is a 1000 location. Data value is 18. Just I am writing 1001. Next location 1001 byte addressable. That's why consecutively I am writing. It is contain one only. Okay. So
Okay.
it is contain every question you have to first write in this way. Then it will be understood by easy. And then 1020. Like in this way you have to go 1020 and then you have written 16. But nothing I have incremented or decremented, so I am not. After the
So we
1020, it
load,
should be
so we load
1021.
1 into RS. So we load 1 into RS.
That means there is a two register RS and there is a two register RD. And this is memory bank. Now tell me.
So RS becomes 1 for after the first
Yes.
statement. Then RD becomes 1001's value, which is also 1.
See, it is immediate. Remember, it is immediate instruction. That's why I have mentioned. It will be
Yes, sir.
loaded. Now load instruction. Okay, go for load.
So
Now data will be
RD
loaded.
becomes the location, the value of the location 1001, which is also 1.
No, no. RD becomes the effective address of this value. Effective address you have to calculate because it is index register mode. Index register mode or base register mode. In the both the cases, in base register, register contain the base address. Maybe like in this, it will be like in this will be RS 1000. But it is not base register. It is index register. Then 1000 is the base address. Okay. Plus displacement. What is the displacement value? 1000. Then location is the 1000. It is called effective address. Remember, effective address, not value. It's
Okay,
the
sir.
effective address. Effective address. So go to the effective address.
So that also has 1 now as value.
On.
The
is
effective
1.
address 1 as a value, and after that we add RD 2000. Okay, sir, got it, sir.
Add the- And now RD. Now RD's value is what? 1 plus. Now immediate again. Directly add 1. So it is
Ye-
become 1001. Now content become 1001. Because
Okay,
it is a add immediately.
yes, sir.
Earlier
Yes,
instruction was loading. Here adding. Clear? Now
yes, sir.
store.
Yes,
Now store 20. Which location? 0 RD. Again bay index mode. Here 0 plus RD. RD's more value is how much? 1001.
yes,
1001 0 plus 0 means same address. So load that 20.
yes, sir.
Clear?
Yes, sir, got it, sir.
Loaded?
Yes,
Okay.
sir, got it, sir.
Can you solve this? Just solve this. Tell me the answer. Anyone? Is rule number 26 is present to include today's class? Rule number 26. Who is rule number 26? Absent today? Student, can you tell me this question is clear? Prajota?
Sir, I'm still, I'm reading the questions, sir. I'm trying the questions,
Okay,
sir.
okay, no problem. Amit? Karam?
Sir, load
Karam, sir?
immediate 20 will load 20.
Okay, okay, come to the point. First, I have to told solve like in this way. Okay, I'm writing it. Given the following memories value and one address machine, type, remember this point, it is a one address machine. With an accumulator word contain 20 with an accumulator, memory and accumulator. Okay, so I think architecture is just like in this way.
Sir, is answer 50? First question.
Yes,
Sir, answer
let's see.
is
I am
50 for first question, sir.
let's see. Let's check. Let's check. At least you tried. That is a very important thing for me. Answer whatever I don't know, I have to check. Word 20 contains 40. Okay, so I am first writing this. Word 20 contains 40. Word 30 contains 50. Word 40 contains 60. Word 50 contains 70. Maybe it's a 10 byte addressable. Na? Each of the location differ by 10. No problem. LDI 20. So SEC is the my content. LDI directly SEC value will be 20 because load immediately. Here I am not storing load 20. Here load immediately 20. So the content of the SEC 20. Is this point clear?
Yes, sir.
Okay. Now load 20. Now
That
go
will
to the
store
20
40.
location. In here now load 20. Go to the 20. You found 40. So 20 will be override with the 40. Is it clear?
Yes, sir.
Is it clear? Again you go to the load 20.
That will store
Again it is,
60.
but it is mentioned indirect. I mentioned an indirect, though I am not symbol. It is mentioned indirect. It means you go to the 20 location, value is 40. Go to the 40 location, value is 60. So 40 will be override with how much? 60 because it is indirect. Is this point clear?
Sir, but in the second and third steps, how will we understand without the comments that it is direct
Eh,
or indirect?
that is mentioned. Sometimes here it will be like in this way.
Okay, sir.
Here like in this way, or sometimes here it will be given in this way.
Okay, sir. Thank you.
Otherwise comment. Okay. Follow the comment also if it is mentioned.
Okay, sir.
Clear?
Okay, sir.
Here is the LDI 30. Now what is the accumulator current content? 60. Accumulator current content is 60. Clear or not clear?
Yes, sir.
Currently it is now 60. LDI 30. That means 60 is overwritten with 30 because immediate. Nothing I have to consider. Now load 30. Go to the 30. Value is how much? 50. It is direct. So now 30 is override with the 50. Now again load 30. Load 30 you go. That is 50. 50 is the indirect mode. Go to the 50 load 70. So it is contain the 70. So what is the current value?
70, sir.
Huh?
70.
70, sir.
70.
Clear or not clear?
Yes, sir. Clear, sir.
Yes, sir.
See, dear student, these topics can be taught. Just make slide बना दूंगा, दिखा दूंगा, addressing mode finish. बट क्वेश्चन में मैं एड्रेसिंग मोड ऐसे नहीं दूंगा, जैसा अभी दिखा रहा हूँ ना ऐसे दूंगा. आपको सॉल्व करना होगा. विदाउट एक्टिविटी यू विल नेवर अंडरस्टैंड एनीथिंग. इज इट ट्रू और फॉल्स? बताओ तो. अभी समझ में आ रहा है क्या एड्रेसिंग मोड?
हाँ, सर.
अगर मैं एड्रेसिंग मोड पढ़ा के चला जाता तो आप लोगों को लग रहा था कि डिस्प्लेसमेंट और ऐसा ही कुछ और बाकी कुछ नहीं है. अभी देखो इसमें डिफरेंस हो रहा है. सो राइट द क्वेश्चन नाउ. इट इज योर होम असाइनमेंट. Today I will not give this slide. I will give the ISS slide, but this may not be appear. So write this question part. Consider the following program segment of a hypothetical CPU. 3 register R1, R2, R3 is there. Consider that the memory is byte addressable with size 32 bit. Byte addressable. Remember this point. And the program has been loaded starting from memory location 1000. If interrupt occurs while the CPU has been halted after executing the halt instruction, the return address saved in the stack will be like, what will be the return address of the stack? Is byte addressable with size 32 bits. Remember this point, very important to all of you.
So it will be required for the address, like that address column we're making, right? That byte size.
You have to specify and automatically you have to go the references. Can you take the screenshot of your desktop or mobile so that question will be captured by you? Am I correct or wrong?
Yes, sir.
Yes,
Okay.
sir.
All
Sir,
of you
but
took
could you
it?
please share these slides, sir, because it will be very difficult without these slides to solve this
Yeah,
question.
yeah. I will give. Don't worry, but at least you try to solve it by yourself.
Yes, sir.
Okay. So that's also I have given all this theory here. One best example of the mathematics I have given in this case also to solve this problem here I have given. Okay. So that's up to the instructions I have given architecture. This part I will discuss you. Sys can risks, then I will finish it. A lot of things I have to discuss. Okay, I think tomorrow, Monday, we will discuss. Okay.
Okay, sir.
Now tell me what is the topics today's lecture not clear to you? Anything which is not clear to you?
Sir, it's more or less clear, sir, but if we could do this, like if we did a couple more sums by hand, it would be more clear.